Hi, Jade. So I will solve two of the problem in this video that you sent to me. So one of them you sent me three problems, but I actually picked the second one because you're gonna solve number one and number three pretty much the same way. Okay. So we are given geometric sequences, and we want to find the ninth term, right? So actually, let's label things a little bit before we move on. This is A1, this is A2, and this is A3. And obviously, like this sequence is continuing, and you want to figure out what A9 is, okay? So what's happening with geometric sequences, okay? What you have to read, and let's copy the sequence actually over here. Okay, so 18, 6, 2, and all the way. Okay, so what you have to read is that every time you every time you go from one term to the other, you are multiplying by 1/3, or if you prefer, dividing by 3. But it's actually more convenient to say that you're multiplying by 1/3 each time, and you will see why. Okay, so what does it mean? Okay, it means that A1, so A1 is equal to 18, okay? And A2 is equal to 18 multiplied, and now look at this carefully, okay? So it's going to be multiplied by 1/3 to the power of 1, okay? So yeah, let's actually put this. Then A3 is going to be equal to 18. And then to get to A3, notice that you have to multiply by 1/3 twice, right? So you're going to how do you multiply by 1/3 twice? You do 1/3 times 1/3. So it's going to be 1/3 squared. And now you should ask yourself, what is the pattern, right? What is the pattern of this sequence? How could I find A9 without actually doing this process 9 times? Okay, well, let's have a look. One thing to consider is that we always have 18 in every single one of them, okay? So what we want to do at this point is we want to write a formula for AN. Okay, and let's actually color code it. Let's put the N in purple. It's very similar to blue, hey? So let's go ahead and use orange instead. Okay, well, this 18 is your A1. Okay, so it's gonna be like A1, right? This, because like that's what it is, right? It is A1. And now the 1/3, we call this the ratio. Okay, so R is equal to 1/3. So it is the amount by which you multiply every single time to get the next term of the sequence. So it's going to give you R to the power of. And now this is the exponent here is a little bit tricky. So follow carefully. So here you have 2, here you have 1. Okay, so when n is equal to 2, then the exponent is 1. When n is equal to 3, the exponent will be equal to 2. So in other words, what you'll have here is to the power of n minus 1. So the exponent of r will always be 1 less than the term of the sequence. Okay? Now, one thing you might wonder is what's happening at 1? Okay, so what the heck, right? Well, you could write here 1/3 to the power of 0. And why is that? It's because anything to the power of 0 just gives 1, right? Hopefully you have learned this previously. So the pattern that you wrote over here also works with A1. So it's gonna work for every single term of the sequence. Okay, now going back to here, okay, you want to figure out what A9 is. Well, once you're here, you simply need to write down the formula. So A9 will be, so your A0, what is A0? It's 18, A1, sorry about that. So your A1 turns out to be 18. Now the ratio is 1 over 3. Okay? And now finally, the exponent will be 9 minus 1. So in other words, it's going to be 8. All right. Now, depending on your teacher, he might expect like you to simplify this. And if you need to, here's what you're going to do. So 18 is 2 times 9, but more precisely, it's 2 times 3 to the power of 2, because 3 to the power of 2 is 9. Okay, so that's the first thing to consider. And then the fraction, you can also reduce this to over 3 to the power of 8. And this means that if you fully simplify your answer, you're going to get 2 over 3 to the power of 6. Okay? And 3 to the power of 6 is a huge number, okay? So if you look in your calculator, it's going to be something like that's really, really huge. So if I was your teacher, I wouldn't expect you to simplify this further. Now, you might wonder about the 3 to the power of 6. How does that work? Well, 3 to the power of 8 is 3 times 3 times 3 times 3, 8 times. And 3 to the power of 2 is like 3 times 3. So in other words, there's 2 of these 3's that cancel. So that's how you get this result. All right, hopefully that makes sense for this guy. How about this? The third and the eighth term of a geometric sequence are 8 and 1 over 4. So what is the first term and what is the common ratio? Okay, so now what we need to do is to use this formula that we deduced in the first number, and we need to work backwards. Okay? So let's actually do it. We have like A3. Okay, so A3, okay? We know that this is going to be A1. So let's actually color code A and R, because as you can see, this is what you will want to find. Actually, we call this A, but let's just keep it as being A1. So A3 is equal to A1 R to the power of 2. So yeah, let's actually not color code this. And we are given that this is equal to 8. Okay? We are also given that A8, which is also equal to A1 R to the power of, but now the R is to the power of 7. And the result is 1 over 4. So now to figure out the ratio, what should you do? Well, if you divide one by the other, the A1s will cancel. That will give you the value of R. Okay, so let's do A8 divided by A3. So in general, take the largest one divided by the smallest one. That will work out more nicely. So what you get is A1, A1. Then you get your R to the power of, now be careful, right? The 7 is at the top, and then the 2 is at the bottom. Okay? Then what's up after? Well, the A1s cancel exactly. As for the R, what you get here is R to the power of 5. 5 being 7 minus 2, right? So keep that in mind. The way you find this 5 is you subtract the exponents. This is R times R times R 7 times. This is R times R. So 2 of them cancel. Okay, so this is R to the power of 5. And now we know what value it has. We know that A8 is 1 over 4. And we know that A3 is equal to 8. This means that R is the cube root of this value. Now, 8 times 4 is 32. So let's actually bring that down. We have 32. And now we need to take it to the power of 1 over 5. All right, now how do we do this? Well, we hit a lucky number here, that 32, because it turns out that 32 is 2 to the power of 5. Okay, um, so in other words, and by the way, you can also distribute the exponent here, 1 to the power of 1 over 5 and 2 to the power of 5 to the power of 1 over 5. And how do these exponents work now? Well, 1 to the power of 1 over 5 is simply 1. 1 to the power of anything is 1. Okay? However, this guy, what you get is 2 to the power of 5 times 1 over 5. So that is the important thing. So you're going to have here 5 multiplied by 1 over 5. So whenever you have like an exponential to the power of an exponent, you can simply multiply the exponents together. So this means that r is equal to 2, simply 2. Okay, so now I will erase this thing. So now that we have that r is equal to 2, it remains to find the a1. Well, we're going to choose, let's say, a3, because it's the easiest to compute. So let's put it this way. To find a1, okay, we know that 8 is equal to a3. Okay, so the a3 that we have like down there. And we know that this is a1, and we now have the value of r. Okay, so r is equal to 2. Oh, shoot. What did I write here? Oh, it's not 2. I made a huge mistake. Sorry about that. So it's going to be 1 over 2. Okay, so my board was being crammed over here, so I forgot that the 2 was actually at the denominator, right? It's 1 over that. So the result is going to be 1 over 2. So let's replace it here. 1 over 2. All right, then the rest is just to literally calculate this, okay? So, all right, 1 over 2 squared will give you 1 over 4. So you will have overall, let's actually write it right underneath. You're going to have 8 is equal to a1 multiplied by 1 over 4. And now the rest is pretty easy because you just multiply both sides by 4 and you get that a1 is 32. You got it. Hopefully I didn't go too fast because I don't know exactly your level. So I don't know the level of explanation that I should be giving. So the rules of exponents, as you can see, are very important. It's important to realize that whenever you have something like this, you need to subtract the exponent. And it's also very important, as you can see, when you have something like this, so 2 to the power of 5 to the power of 1 over 5, that you multiply the exponents together. So 5 times 1 over 5 giving you just 1. This is why the ratio is a half. All right. Good luck, manhood. See you in the next video.